Hey there! Today we're diving into a pretty interesting problem involving memory management in C++. The problem we're facing relates to the efficiency of handling large amounts of data within containers. Specifically, we're looking at a scenario where a vector implementation switches to a stable vector utilizing virtual memory after hitting a certain capacity threshold. However, there's a range where copy operations become significantly more expensive, and we're on a quest to find a solution to optimize memory usage without compromising performance. Now, let's talk about the solution to this memory management challenge. By leveraging functions like create file mapping and map view of file X in Windows, we can manipulate memory addresses without the need for costly copy operations. The key lies in creating a file mapping back by the system paging file and then mapping the allocated memory into the virtual address space of a program. By following a specific sequence of steps, including unmapping the old memory address and creating a new view at a different address, we can effectively move memory without engaging in copy operations. Moving on with our discussion on memory manipulation, we can witness the seamless transition of data between different virtual memory addresses using the provided code snippet. The code demonstrates the successful read and write operations at distinct memory locations, showcasing how the content can be accessed without the overhead of duplication. This method not only ensures efficient memory utilization, but also enables smooth data handling within the program. Additionally, an alternative approach to optimizing memory allocation involves reserving a significant chunk of virtual memory space upfront, allowing for flexible expansion as needed. By strategically reserving and committing memory pages using functions like virtual alloc, we can allocate memory resources judiciously based on the container's requirements. This method offers a balance between resource allocation and performance, providing a practical solution for managing memory effectively. In summary, we've explored innovative techniques for managing memory efficiently in C++ containers, addressing the challenges associated with large data volumes. By implementing strategic memory manipulation strategies and leveraging Windows functions, we can enhance the performance of our applications while minimizing unnecessary copy operations. I hope you found this discussion insightful and helpful for your programming endeavors. Remember to subscribe, like, and share your thoughts in the comments below. Happy coding!